Hi everybody, my name is Pascal Potvin and I was recently participating in the Ericsson Hackathon October 27 and 28 from the Montreal location. Our small project was around the Montreal street parking. I was lucky to be part of a team of 5 talented peoples who I want to thank: Marc-Olivier, Antonio, Maddie and Mark. Thank you guys for this formidable experience. Our team goals was to display a map of the city of Montreal with color-coded street sides to indicate if it's allowed to park on the street at a specific time. We wanted to use the City of Montreal open data, namely two databases from it, the parking side information and the street side information. The Montreal parking sign information consists in an Excel file of more than 300,000 signs. The Montreal street sides information consists of a GeoJSON file of more than 100,000 street segments. Those street segments normally cover one street corner to another, so at a minimum they consist of 2 points per segment, but curved road obviously contains more points per segment. I'll cover the details of the geoparsing in the next slides, but that task alone took about 17 hours of processing on one of our servers. So the first task was to do some geoprocessing and associate each sign from the first database to a specific street segment in the second database. That was my main task during the hackathon. So for each street sign's entry, we needed to find out which street segment is the closest. Since each street segment is made of a number of points, this means to calculate the distance to each subsegment. According to Wikipedia, this is what it involves. In order to cut on processing time, we first find a number of streets with segments whose points are close by, as you can see in this picture. So what we did is, instead of calculating the distance to the street subsegments, we first calculate the distance to each point in that segment and keep only the closest one. Then for that subset, we calculate the exact distance to the sign and keep the closest one, the red one in this case. It's probably good to mention as well that we need to compensate for the latitude. As you can see, this formula applies for Cartesian points, and except for the Flat Earth Society members, most of us now know that the Earth is kind of spherical. So for the distance calculation, we apply the cosine of the latitude to the longitude, and to compute the actual distance, if needs be, we can use the approximation of 111,320 meters per degree. This is, at any rate, a good enough approximation to find out to which street segment a sign is closest to. The next task was handled by other team members, and it consisted in parsing the text of the street sign and build a computer-understandable rules as to when parking was or not allowed. So these guys parsed the 300,000 signs and more in order to get the simple rules. Finally, both results were put together in an Ericsson-looking website we built for that purpose. Streets in green are parkable at the specified date and time for long duration, yellow are parkable for less than 4 hours, and red are not allowed to park on at that time. You can obviously move on the map, zoom in and out, and the refresh rate is quite good. Some of the tools we use for this project: for maps, we use the trio of Leaflet, Mapbox, and OpenStreetMap. For the data crunching, we use Python, Pandas, Jupyter Notebooks, NumPy, and Folium. And for the final website, we use Python, Flask, jQuery, and Ericsson CSS, obviously. Finally, some reference if you want to dig further to the Montreal open data: Leaflet, Mapbox, and OpenStreetMaps. In conclusion, this hackathon was really fun. Producing map using Leaflet proved to be really easy and straightforward. The data crunching beforehand proved to be way longer than anticipated, and even after putting in improvement to make it faster. There's probably more that could be done to improve speed, but the hackathon time is over. The text parsing of the sign also proved harder than anticipated. All in all, it was a nice hackathon working with great guys. Thank you, team. And thank you all for listening.